Hey everyone, I'm Samhita. I'm a machine learning engineer and tech evangelist at Union. Today I'll be talking about custom container plugins in Flyte. Let me share my screen. Yeah. Right. So here's the outline for today. Firstly, I'll be talking about the types of Flyte extensions we have, and then the differences between custom behavior and custom container task plugins, followed by takeaways and SQL Alchemy plugin code walkthrough. We have 4 types of Flyte extensions in total. The first one is custom Flyte type. So here you see this example wherein we have a task, which is called my task. And in that we have CSV file, which is a parameter. It has this custom type. So the basic meaning of this is CSV file has this custom type. Now, custom type doesn't have any meaning. So it's our job to define the functionality for this custom type in Flyte Python SDK. Now, this is custom Flyte type. Now, what is custom container? Custom container is author defined. That means it's the job of the author to define the Docker image that this SQL Alchemy or any other such task has to run in. Now, what is custom behavior? Custom behavior uses user's container, meaning the user has to provide the Docker image in which this particular task has to run. And then there's backend only, which is like a combination of Flyte and Flyte Propeller. You'll have to make some changes in the backend in order to make this work. Let's look at the differences between custom behavior task plugins and custom container task plugins in order to know why custom container task plugins fare better than custom behavior task plugins. I'll go through each point one at a time. At serialization time, a Docker container image is required. The assumption is that this Docker image has the task code. Whereas in a custom container task plugins, the Docker container has to be provided by the author, not by the user. So this statement means that in custom behavior task plugin, the Docker container image has to be given by the user. Serialized task contains instructions to the container on how to reconstitute the task. In our custom container task plugin, serialized tasks should contain all the information needed to run that instance of the task. This means that in a custom container task plugin, the serialized task in itself has all the information that is required to spin up the instance. Whereas in a custom behavior task plugin, the serialized task has to send information to the container, which again helps in kind of rebuilding the task. When Flyte runs the task, the container is launched and the user given instructions recreate a Python object representing the task. Whereas in a custom container task plugin, it all depends on the executor. The executor has to run that particular task. The primary difference between custom behavior task plugin and custom container task plugin is that custom behavior task plugin is task dependent, whereas custom container task plugin is executor dependent. Executor is like a layer that's put on top of task. Going on to the next difference, the task object that gets serialized at compile time is recreated using the user's code at runtime. In a custom container task plugin, the task object that gets serialized at compile time does not exist at runtime. It's because we have executor. We don't need the task anymore. It's the job of the executor to run the task. At platform runtime, the user decorated function is executed, whereas in a custom container task plugin, there is no user function. It's the job of the executor to produce the outputs and accept the inputs that are given to the task. Here are the takeaways of custom container task plugins in general. Custom container task plugin helps in shifting the burden of writing the Dockerfile from the user to the author. The user needn't worry about writing the Dockerfile anymore for that particular task. And it also allows the author to optimize the Docker image. We needn't depend on the user, so it helps the author to optimize the image. Let me do a code walkthrough now of the SQL Alchemy plugin that we already have. Right. So here's the directory structure that we'll have to follow in order to write a plugin. It could be a custom behavior task plugin or a custom container task plugin. Plugins folder is present below the Flyte folder. In plugins, we have to write the plugin. Now our plugin is Flyte SQL Alchemy. In that, we have Flyte plugins followed by SQL Alchemy. Now this is the structure that we'll have to follow in order to respect microlib way of writing plugins, because that's what we are following in order to write the Flyte plugins. Make sure you have the plugin name followed by Flyte plugins followed by the folder name. Now, you access this plugin by using flyteplugins.sql alchemy package. This is defined in the setup.py file that's present within this particular folder. Here, if you see, this is the package name. This is how you'll have to install using pip. And this is how you import the code in the file, in the code file. All right. Let me go through each file in here. Firstly, I'll be talking about the Dockerfile. Now, since it's the job of the author to write the Docker image, we'll have to have a Dockerfile. It needn't be present in this folder. I have put it in this folder because it merges well with the code that we have. So here we have Python. We also have a couple of requirements that we are installing. If you see in here, requirements.txt. Let me go to requirements.in. So this is what I'm installing in here. One is Flyte and the other is SQL Alchemy. Yours could be a different requirement. So you'll have to put the list of requirements that you want to install within the plugin. After you have your Dockerfile and requirements, it's your job to build the Docker image. You'll have to build the Docker image. And after you build the Docker image, just push it to a Docker registry. It could be anything. I have pushed to GitHub registry. If you see here, I'm using a GitHub registry to push my image, and I'm using that particular image in here. I'll go through each code snippet in here. Firstly, I am using SQL Alchemy config, which is a typical SQL Alchemy configuration in order to connect to the database. And then I have two important classes that we have to mandatorily define in order to write a custom container task plugin. One is SQL Alchemy task, and the other is SQL Alchemy task executor. In general, this is called the task class, and this is called the task executor class. Now, in task class, I am subclassing Python customized container task. You will have to do this. This is where the task template or the custom thing is written. And then we have the task type, which is SQL Alchemy. This basically points to the plugin that we are going to use. If at all this plugin is not present, then it defaults to the container plugin that we are using in here. And we have the init method. In init method, you pass in some parameters. It's desk name, query template, the query that you want to use, task config, which is this class, inputs, a couple of inputs, and the output schema type. By default, the output schema type is Flyte schema. And again, I am calling the init method of this particular class. I am passing in the name, task config, container image. As I've mentioned before, the task, the executor type, which is this particular class, the task executor class. You'll have to mention this name in here, and the task type and the rest. This is a property that I've defined, and then the get custom. Now, get custom is used to serialize the task template. It means that you written some specific set of values that you are going to use when running the task. Now, this task is run by this particular executor. Here, I'm returning 4 values because these are the values I'm going to use when trying to write my functionality. Now, moving on to this task executor class. This task executor class subclasses shim task executor, and it has this method called execute from model, which accepts task template parameter. Now, this task template can be used to extract these values. This is how you do it. tt.custom secret connect args. Now, this extracts the value that's defined in here. The same way we extracted all the values that are required, we follow a typical logic wherein we are connecting to the database, interpolating the query, meaning replacing the variables with the actual values, and then running the query, generating a data frame, finally returning the data frame. So this is the job of the task. This is where you'll have to encapsulate all of your business logic. Finally, out of the box, the task template task will run a command that looks like the following when the container is run by Flyte. So this is what gets run when you call this particular task, SQL Alchemy task. This is what gets triggered. All right, this is how you write a task. That is it. It's that simple. And then let me show you how you can test this particular task. Now you have written the task. Now it's you want to test it. So how do you do that? You have a folder called tests. This one in plugins. In tests, you'll have to create your respective folder, whichever is related to your plugin. Now mine is SQL Alchemy. In SQL Alchemy, I have my test files. So these are the plugin test cases I have written to make sure that my plugin is working correctly. Yeah. And then this is an example file that I've written. So this is how you'll have to call your task after you write your plugin. Say you're writing this particular example in Flyte Snacks, then you just do this part. You call your SQL Alchemy task by passing in the required arguments. And then you are running this task within this workflow by passing in a limit value to limit the number of records that you want to fetch from the database. And then you get the data frame, and I'm again passing it to a task, returning the length of the data frame. This is a very simple functionality that I have implemented to showcase how easy it is to use a task. Yeah, so that is it there. And you have to make sure that this task, this particular file has all the requirements. You have to make sure that it has the requirements file. It has the Dockerfile wherein you give this particular plugin, you give this Flyte kit. These all have to be installed on top of this. I'll pass the baton on to Haytham, who will be showcasing this particular example from the user's perspective.
Awesome, thank you, Samhita. That was it was pretty cool. So for my part of the demo, I will be talking about how do you take it to sort of the next level of testing. So what Samhita showed is, how do you start writing a new plugin, right? So you go to the Flyte kit repo and make all of these changes, and you test it locally. And the idea is that you catch all of the bugs as quickly as possible, and like as soon as possible, I should say, right? Before building containers and all of that, right? You're just iterating quickly on your code locally. You can test your tasks, how they get serialized, how they run, all of that, right? But no matter how much like testing you do, behavior could be different when you actually run remotely. You might have missed or made some assumptions about the existence of certain dependencies and so on. And this is where this next step comes in. We have this repo called Flyte Snacks. I'm pretty sure most of you guys are familiar with. It has all of our examples that are, in most cases are like ready for copy paste. So if you want, how do you want to learn how to do like conditionals? There are like a bunch of examples that you can just copy. How do you use a particular plugin? You will find the directory there. You can just copy the example and the make file, the Dockerfile, all of that. They're like ready for that consumption. It's also a way, this is how we generate the documentation and so on. So after you develop a plugin, we ask everyone to write sort of a formal example with documentation and so on here, so that it serves the purpose of documenting how people should use the plugin, but also has the code that they can just copy and use, and we can validate that the plugin works as expected and so on. The directory structure is a bit complex, I have to admit, but where most of those plugins will show up is under integrations. So these are, we put where you integrate with external systems. In most cases, you see AWS and others. And under Flyte kit plugins, these are the we call them here FlyteKit plugins. Those are the plugins that that Samhita was talking about, where we provide a custom container that runs the task for the user. There are already a few examples here, and I just added this one to demonstrate the plugin Samhita showed. There are a few files here, so we'll go over those. I know I tried to make the sidebar navigation here bigger, but I could not, so excuse that. I hope you can read the text though. So this is a very simple file that has the plugin, the task that uses the plugin. We import that, and the workflow that just calls this one task. You will notice here that I did not need to add a Dockerfile because there's no, I as a user, I'm not writing any custom code that needs to run. And the author of this plugin provided, all the necessary containers that need to run this task. So I have my file with the code, and then I have a requirements file that just needs FlyteKit and this very long, arguably too complicated requirement. And this is how you can pip install a package, a remote package of sorts that has not been published to PyPy yet, right? At a later phase, after you have validated all of this, you'll be like, this is good to go. Then you publish your package, and we have tools, the tool chain in FlyteKit to do that to PyPy. But before you do that, you still need to run your example, and this is how you can do it. You can reference a particular SHA. You can also go back and make changes to your FlyteKit, like plugin, and come back, update the SHA here. And you can reference the subdirectory. This is what I did here to install this one plugin, right? So it will get the released version of FlyteKit, the publicly validated FlyteKit version, plus your new plugin installed. This is our requirements in, and we can run the requirements pip compile somewhere. Here we go. So, oh, I am in the directory. Right, so while that's running, we can take a look at the rest of the files. There is a FlyteKit config file. This is what tells FlyteKit at serialization time what package. Well, it has a lot of other configs, but the only one we really need is this that tells FlyteKit when PyFlyte, when we serialize this directory, what packages to look at. To like serialize or extract workflows and tasks from. And in my case, this is, I'm referring to the SQL Alchemy simple. Oh, here we go. Yeah, so pip compile finished, and you can see it pulled in FlyteKit, obviously, and my custom requirement, as well as everything else that FlyteKit pulls in. So there's that, yeah, and then yeah, so that's pretty much it. So you just need these 1, 2, 3 files. You can then run PyFlyte register, and I have that here. So we say, is this big enough? The text here. Hope so. So it says PyFlyte, and then -c passes the config file, which is the wrong name. Like kit config, serialize workflows, and like it says, serialize the outputs to this directory. So you can run that. And I need to create a directory first. Pd output. Here we go. We can also inspect the output here. It generated those 3 files. This is the task. I have one task, and then the workflow that's represented here. And this is what gets automatically generated. It's a launch plan, what we call a default launch plan for the workflow. We can talk about that in a separate discussion. And then after you're done, so this is, so you validated now that the task and the workflow can serialize correctly, right? There's some validation that happens here at FlyteKit side, like, you know, some typing checks and others. So this is an important step, right? And then the next step you do is you register those generated files. And for this, I am using FlyteCTL. FlyteCTL register files. You pass in the all the files here with the config and project and domain. Register that. I think it might, yeah, they're already registered. I can pass a different version. You can say that there's version, you know, OSS demo 1. And the output, yeah, so everything successfully registered. I can jump back to my window here in a second. Here we go. So this is our development environment. Okay, I hope that's visible. So yeah, if I search for SQL Alchemy, we'll see my workflow got registered and the version I picked is here. And then you can just launch it from the UI and so on. You can also launch it from FlyteCTL, but I find this for simple workflows easier to use. So you can just launch it or pass inputs or whatever. Yeah, of course, you might find bugs. It might not run as you would expect, and you will like go back through the development or the iteration cycle again, go back to the plugin, validate your changes locally, make sure you write unit tests for them as Samhita showed, and then you repeat the cycle. These are I think the most important probably steps in like a development cycle for a new plugin of that type. We did really want to go through this workflow because I think it shares a lot with all the other task types or plugin types that we will be demonstrating in like future walkthroughs. And for those, we want to focus more on the logic and how do you customize those plugins. And then the same workflow applies, right? You write it first in FlyteKit, you validate, unit test, and so on. You publish stuff, and then you test it in like a remote sandbox with documentation. Hopefully, yeah, hopefully this you find this walkthrough useful. Encourage more contributions for a lot more task plugins of this way, of this type. I think we were maintaining a list of integrations that we think are suitable for this kind of integration, and we can share that maybe afterwards if anybody is interested to get started. We'll definitely love to help you. So reach out, Slack, you're all there, and we'll help you, in the development of these plugins. Anything you want to add, Samhita?
That's it.
Cool. Thank you. Any questions?
I guess maybe I'll ask a question instead of adding something. So when would you choose to use the demoed custom behavior with container supplied plugin instead of backend plugin? Or let's actually take the simpler example: container supplied custom behavior versus a regular FlyteKit Python task type plugin. When would you choose to use which one and why?
Yeah, do you want to pull up your slide on that, Samhita?
Sure.
Yeah, I think that's a very good question. I think it applies to all the other types of plugins too. When do you choose to use which? The maybe takeaways, slide 6. Right, so the main use for this kind of plugin, the custom container task plugins, is that you, as a user of like the end user who is using these tasks, they do not have to worry about dependencies or conflict of dependencies, building Docker files and maintaining those Docker files and optimizing the runtime of these Docker files. All of that can be maintained independently by the plugin author. And they are arguably going to be the best at doing so. They know, how to run, I don't know, SQL Alchemy best, the best type of like base image to use, the most optimized, and so on. I think there is also, like, at scale, there are benefits when you run these tasks a lot in your company. These images will be cached on the servers where Flyte runs. So like you will see at scale performance improvements in running these type of tasks. When you shift it to the user, the custom behavior with user containers, you get so you lose these benefits, but what you get is access to user code, which can give you more, or can allow the user to customize the behavior even more, right? So you can provide, as a user, you can provide custom logic, maybe a function or something that will run, maybe in the case of Spark, for example, right? The Spark code cannot be expressed declaratively. It runs like dynamically, and the user has to supply that. So when the user has to provide logic that has to run at runtime as code, you cannot use the custom container only task plugins. You have to go to the custom behavior where you involve the user container in the process.
Can I paraphrase that last bit just for me to understand and probably everybody else to understand? So the time when you should prefer the custom behavior for the author supplied container plugins is essentially when the task plugin specification or the task specification is completely portable. That means you can move it from users' code wherever they are on their laptops, hopefully on the web or wherever, from there into the container at runtime, which SQL in this example, the one you demoed, is extremely easy, right? It's just text. You can move the text from the user's code into the container. Is that right? Okay.
Yeah.
And if so, then, but that doesn't mean that code cannot be moved, right? You could move the code. If you could serialize the code as text and move it over, and you have all the dependencies. Now, the problem with that is that the dependencies, if you depend on, let's say, a TensorFlow, for example, and this plugin was not doing anything with TensorFlow, it will not work. Right?
Yeah.
Okay.
Yep. And if you and there is, I guess, a fine line there. Like eventually you'll be rebuilding Docker, right? Like if you package the user's code, their native dependencies, their pip dependent, right? You are essentially rebuilding Docker, and you're probably not what you want to do.
Yeah, I just wanted to understand, draw the line.
Yep.
Yeah, but I think as a takeaway, these are the types of plugins that we'll see more and more often. It's a great way to introduce plugins that are controlled using FlyteKit, but not need a backend plugin. So you don't need to know any Go to write these kind of plugins, and yet they are completely controlled by the plugin author, not by the user. And that has a lot of benefits because you can, as Haytham mentioned. So like, let's say if you want to have a way to interact with Dataproc or Dataflow or whatever, and it's just uploading jars, it doesn't need to be a Golang backend plugin. And there are benefits of using a Golang backend plugin. So get into them into the future. Like no need to run a container, and that's a huge benefit. But that's not required as a step one. This is an excellent step one, and the cool part about these plugins is that slowly you can migrate them to a backend plugin without needing any user code behavior changes. For them, they were running a container, and then tomorrow they start running a backend, no container code, and it's still the same because their workflow is the same. They don't have to build a container. They don't have to think about where it's executing, how they are executing, what are the dependencies, and so on. They just write the code and it works. I think that's probably the way to think about this. And I think that's where I saw Haytham in his example had Snowflake plugin, because you could do Snowflake like this essentially, that you can write a query that executes in the Python pretty much easily, much easy to write Python plugin for Snowflake, and then later on easily migrate that to a backend plugin to for calling Snowflake service directly from Propeller.
Yeah, and the nice thing about that is from an end user perspective, that code will look pretty much the same. Still, you just say my task, here's the query, and that's it. And then because of how standard the serialization and everything else is, this could end up being a separate container like these plugins, or running in the backend. In either case, you don't need to involve the user container, and it's completely transparent. And it's a very nice, it's a very nice, I guess, upscale. So you can start with it's an experiment. You don't know how many people would use it. If a lot of people start using it, then you invest more into a backend plugin and get the benefits that, yes, we will talk about in a future walkthrough.
Any questions? I'm going to put Jeev on the spot because he clapped.
No, this is great. I learned a lot today. I haven't had a chance to think about how to use these yet, but we'll definitely look at the examples.
Yeah, like I think we've talked about, though Gleb has added BigQuery plugin, but if you don't want to use BigQuery directly, this is probably super fast way to get there.